In this question, we are required to find the complete range of values of a such that 1 upon 2 raised to the power modulus of x is equal to x square minus a, right? So this equation must be satisfied for maximum number of values of x. Okay. So whenever we see that two different functions are being equated, we can say the left hand side function as x fx and right hand side one as gx. So we see these two are different functions and they are being equated. So what we try to do, we try to plot graphs for them if feasible. Okay. And then we plot both of the graphs on same plot and then see if they intersect or not, right? Okay. So before starting the graphical transformation method, we have to notice one slight thing that wherever for a raised to power x, there are two cases possible. One where a is less than 0 and other one where a is greater than 0. For a is less than 0, we have to learn this graph, right? The graph behaves like this, right? And when a is greater than 0, graph is going to behave like this, right? Okay. So this thing we have to learn by heart. There is no alternative for that. And we can also see one basic thing that a cannot be equal to 1 because then the graph will become constant and it won't be any of our use. Okay. So for simplicity, we are going to write half as 0.5. Okay. So now how we plot the graph of fx? So we start very basic thing. We plot 0.5 raised to the power x. Okay. Let's ignore modulus for once. And since we already learned previously, when a is less than 0, the graph looks like this, right? Okay. Now let's see what's the other transformation. Now we have to put modulus to this thing. Okay? Okay. So when we put modulus, so what's the rule of applying modulus transformation is that we eliminate the negative y or negative x part, right? So this thing modulus cannot handle, right? It only can handle positive values for all x, right? Okay. So we need to ensure that all the values of y are positive, whether the x is negative or positive. We can only generate positive values. So we'll ignore the negative part, right? Which the part is on other axis, which is coming from negative axis of x. And we'll focus on the part which is on first quadrant only. Remember, in first quadrant, this part is there. So we are going to apply the mirror image of that part about y-axis, right? Then we'll get modulus x. And for negative as well as positive value, modulus have to give same value. That's why the graph has to be symmetrical. It cannot be asymmetrical. Okay. So now we are done with our fx graph. Now we have to plot for gx graph, right? So we'll draw the basic graph of x square. So for y is equal to x square, we are having an upward facing parabola. This we must know by heart, right? Then we'll subtract it with a. We can also see a minus a. So the rule of this transformation is that gx was our function. So gx transforms to gx minus a, right? So whenever there is involvement of an external operator and a constant, then the graph will either move upwards or downwards depending on the sign. So if there is a negative sign, the graph is going to shift a units downwards, right? So now we have shifted it and we'll always plot the peak points for our convenience so that when we plot both the graphs, we don't get confused. Okay, so now I have plotted both the graphs on the same plot and we can see that it intersects at 2 points, right? Let me just focus on this graph. Okay, so now was our condition that we need to solve for maximum possible values of x, right? So this graph is fixed, this blue one. We cannot change that. So what we can change is value of A. Accordingly, this red plot is going to shift, right? So is there any case where we can have less than 2? Yes, we can. When we put minus A, when we put A as -1, then we can have this parabola shifted upwards. But we have to solve for maximum roots of x, right? Roots of fx and gx when they are equal. So maximum is only possible in this case. So minus a can never be equal to 1, right? This is very clear. But we need to find the range of values, and we know that a can take any value. But how will define the bound? Minus a always has to be less than 1, or alternatively we can write this 1 must always be upper than minus, right? So that's what we wrote here. So 1 is greater than minus a plus 1 is greater than 0, a is greater than -1, and finally we get the range of values of a, right? So we finally got the range of values of a, and that's what we had to find, right? So this is our correct answer, D option. See, it is so easy to use graphical transformation. We don't need to substitute anything or apply some algebraic equations. That's not at all required.